Hey guys, this is part 2 of chapter 2, section 1. So if you watched part 1, thanks for watching part 2, but I want you to go and take a wild stab at what the answer might be to number 4 if number 3 ended up being no solution. So while you ponder that, I'm going to go ahead and get started on these two equations. So let's do this guy over here. Got to have slope-intercept form. So let's move the 4x. And how do we get rid of the 2? We got to divide by 2. So divide the first guy by 2. I get that. Divide the second guy by 2. I get 2.5. Now, as far as graphing that, well, how are we going to graph 2.5 accurately? So, I mean, no big deal. You could go, hey, I'm going to say 2.5 is right about there. But if the point is to see where the lines cross, well, you want to be as accurate as humanly possible. So I'm going to show you another thing you can do here. You could also make your graphing grid a lot bigger. That might be helpful. So nowhere does it say that the grid marks have to count for 1. So how about if I made them count for a half? So I could go, this is half, 1, 1.5, 2, 2.5. So my y-intercept is 2.5. The only thing, if you're going to do that, you should really indicate on the graph that the grid marks are worth a half. So I got it. So my slope's -2. Now, even though the grids are worth a different amount, you can still count the slope like you normally would. So if the slope is -2 down 1 over 1, I could still go down 2 and over 1. It still works. Down 2 over 1. So notice that my line tilts to the left, and I should know that for a fact because of the slope being negative. So let me get a line going here, and then we'll get that other one. And again, if you watched that first video, I was harping on the people that made this Screencastify app. It doesn't put arrows on the ends of its lines, even though it indicates it here in the drawing. But please, if you are doing it, put some arrows. Okay, so here we go. Second one. Well, pretty close to being y by itself already. In fact, I'm not going to bother rewriting it. I'm just going to say, to get y by itself, you would need to move the 2x to the other side, negative, and I got it. Well, guess what? 5 halves is the same as 2.5. So if that's 2.5, and that one was 2.5, and that slope was -2, and that slope was -2, same line. So I'm not going to bother to redraw it, but I would have to draw this new line right on top of the old line. And if you watch video number 1, you would know what the answer to that is. And if you didn't, I'm going to repeat it. So we don't want to say all real numbers because that would mean anywhere on the graph. And we're just specifically talking about the coordinates that are on, bingo, bingo, or and even here, on the line. So what we want to say is infinitely many solutions. Now, some teachers, including myself, are going to be nice and let you abbreviate that. So IMS stands for infinitely many solutions. And hopefully watch video number 1, which we had already talked about. Okay, hey, there's one more detail down here, and I don't quiz people on this, but I'm going to mention it anyhow, just so you know it. Mathematicians like naming stuff, just can't seem to help themselves. So consistent and inconsistent would be, which type of graphs were we looking at? Well, here's basically what it means. Consistent means there's an answer. So an answer would have been, obviously, if you had 2 lines and they cross somewhere, there is an answer. And that answer is right here. The one we just did a second ago ended up being just one line with the second line on top of it. But that has an answer is infinitely many answers. So inconsistent would be the guy that doesn't have an answer. So hopefully if you watch the first video, and actually that's shown up above if you want to look at that example, it's already done for you. If you get a system that's parallel lines, and parallel lines obviously don't cross, there's no answer to that. So that's termed inconsistent. And then they will go further, because again, mathematicians like naming stuff, and they will divide it up even more so for you. So they would say, this guy here Well, the one line is kind of dependent on the other line, right? Because they end up in the same spot. So the infinitely many solution one is called dependent. And that must mean that the guy has one answer. In other words, the two lines are independent of one another. They go different directions. But they do cross. They do give you one answer. All right, so ACT test maybe. Air test maybe. You might need that information. But I will not quiz you on it. And that brings us to the conclusion of Chapter 2, Section 1 notes. As always, thank you for watching.